Hello class, this is Ms. Sherman. I put together this video tutorial to briefly go over calculating anesthetic and vasoconstrictor dosages. Each patient is going to be limited in how much anesthetic they can receive, either by the amount of anesthetic drug or the vasoconstrictor. Unless the patient is receiving an anesthetic without a vasoconstrictor, it's important to calculate for both of these to determine which one is the limiting factor. Some patients will reach their maximum based on anesthetic drug, and some will receive their limit based on vasoconstrictor, and much of this is determined by their body weight. To begin, you will need to be familiar with several charts that are in your book. The first is Table 7.1, the maximum recommended dosages per appointment, found on page 89. Page 7, box 7.3 on page 90, the drug dosages per cartridge, and box 7.4 on page 93, the volume of vasoconstrictor per cartridge based on the dilution ratio. The other table that will be important to know is Table 7.3 on page 93 that gives the maximum safe dosages of vasoconstrictor. This chart will not be provided, but it is pretty easy to memorize. Basically, a healthy patient can receive 0.2 milligrams of epinephrine per appointment, but a heart patient can only receive 1/5 of that, or 0.04 milligrams. The limit for levonorephrine is 1 milligram for all patients. Now, once it's been determined which anesthetic drug you will be using on a patient, whether it be lidocaine, articaine, mepivacaine, or whatever, you will need to keep 3 maximum recommended dosages, or MRDs, in mind. First, the absolute maximum recommended dosages for whatever particular anesthetic you're using. For example, looking at Table 7.1, we can see a list of the MRDs for each anesthetic. Articaine doesn't have an MRD, but all the rest of them do. The other is the patient's MRD based on their body weight. This must be calculated using the milligrams per pound chart on this same table. The last is the MRD for vasoconstrictors you are using, whether it be epinephrine or levonorephrine, and Table 7.4 gives you those. So let's begin determining the maximum recommended dosages for a 100-pound patient receiving lidocaine plain, meaning that the anesthetic doesn't have any vasoconstrictor in it. Now, the absolute MRD for lidocaine, we can see right here, is 500 milligrams, whether it has vasoconstrictor in it or not. This pertains to anyone of all weights. Now, to calculate the MRD for this particular patient, you would need to multiply their body weight, 100 pounds, times the milligram per pound for lidocaine, which is 3.2. And using my calculator over here, that comes to 320 milligrams. So that patient's MRD is 320 milligrams. Now, this is well under the 500 absolute MRD for lidocaine. So her weight limits her to receive no more than 320 milligrams of anesthetic. But how many carpules is that? So to convert that to carpules, we see that in box 7.3, and lidocaine is 2%, we see that for a 2% solution, there are 36 milligrams of drug per cartridge. So if she can have 320 milligrams, we're going to divide that by 36, and that comes out to 8.88. So she can have 8.88 cartridges of 2% lidocaine plain. Now, what if she was receiving 2% lidocaine at 1 to 100,000 epinephrine? All other calculations are the same. Her limit was 320 milligrams of lidocaine based on her body weight, and she could have 8.88 cartridges based on that. But let's calculate how much epinephrine that would be. 1 to 100,000 epinephrine. We see over here 1.8 milliliter cartridge has 0.018 milligrams of vasoconstrictor in it. So if the patient can have 8.88 cartridges and each cartridge has 0.018 milligrams of epinephrine in it, we would divide that by 0.018 milligrams. That comes to 0.159 milligrams of epinephrine. We remember that the MRD for all healthy individuals of epinephrine is 0.2 milligrams, so that falls below the MRD. So for this patient, the limiting factor is the anesthetic drug, not the amount of epinephrine. So for her, it would still be the 8.88 cartridges of 2% lidocaine. Let's do the same calculations for a patient who weighs 230 pounds and will receive 2% lidocaine at 1 to 50,000 epinephrine. Okay, determine the patient's MRD for lidocaine. So 230 pounds times lidocaine is 3.2, and that is 736 milligrams. Now this is over the absolute MRD of lidocaine, which is 500 milligrams. So this patient cannot have more than 500 milligrams of lidocaine. How many carpules is that? Okay, so we will take our 500 milligrams and we're going to divide that by 2%, has 36 milligrams per cartridge, so we're going to divide that by 36, and that comes to 13.8 cartridges. But let's determine how much epinephrine that is. A 1 to 50,000 carpule, we look over here, has 0.036 milligrams of epinephrine, according to box 7.4. So 13.8 cartridges times 0.036 milligrams of epinephrine per cartridge equals 0.49 milligrams of epinephrine. This is way over the MRD of 0.2 milligrams of epinephrine. So epinephrine is the limiting factor for this patient. But how many carpules can he have at 1 to 50,000? If each carpule of 1 to 50,000 is 0.036 of epinephrine and the MRD is 0.2 for every healthy patient, then 0.2 divided by 0.036 is going to equal 5.5 cartridges. So our 230-pound patient can only have 5.5 carpules of 1 to 50,000 2% lidocaine anesthetic. Let's do a couple more examples. A 150-pound patient has received 3 carpules of articaine at 1 to 100,000 epinephrine. Now, question, how many more carpules can this patient receive before reaching their limit? first notice that articaine has no absolute MRD. So we don't have to worry about that. Next, let's determine the patient's MRD. They weigh 150 pounds. The milligram per pound for articaine is 3.2. So times 3.2 is going to equal 480 milligrams. This patient cannot receive more than 480 milligrams of articaine. But how many carpules is that? So let's take our 480 milligrams, and we have articaine. Articaine is 4%. So we have 4%. Each cartridge has 72 milligrams of drug in it. So 480 divided by 72 milligrams in each cartridge is going to come out to 6.6 cartridges. So this patient can have 6.6 cartridges based on the anesthetic drug. But let's check the epinephrine. If he has had 3 carpules already of 1 to 100,000, okay, so that's 3 cartridges times 1 to 100,000, each has 0.018 milligrams of vasoconstrictor, 0.018 milligrams of vasoconstrictor, so that comes out to 0.054 milligrams of epinephrine. The MRD for epinephrine on a healthy patient is 0.2 milligrams. So if he's already had 0.054 already, then let's subtract 0.2 minus 0.054 is going to equal 0.146 milligrams left. So he can have 0.146 milligrams still before reaching his limit on epinephrine. Now convert this into carpules. 0.146 divided by how much epinephrine is in one cartridge of 1 to 100,000, which is 0.018. 0.146 divided by 0.018 equals 8.1 cartridges. So the limiting factor for this patient is going to be the anesthetic drug itself, articaine, because they can only have 6.6 cartridges of articaine, but they can have 8.1 more cartridges of epinephrine, so you're going to go by the lesser number, the 6.6 cartridges. One last example. Let's say a cardiac patient weighs 190 pounds. And you want to give them mepivacaine, 1 to 20,000 levonorepinephrine. Now the absolute MRD for mepivacaine is 400 milligrams. To calculate this patient's MRD, you're going to multiply his body weight, 190 pounds, times the milligrams per weight of mepivacaine, which is 3, is going to equal 570 milligrams. Now this is over the MRD for mepivacaine of 400. So you'll be going by the absolute MRD of 400. But how many carpules is that? So 400 times 36, because mepivacaine is 2% carbocaine. So it's 36. You're going to divide that by 36, and that gives you 11.11 cartridges. But calculate for the vasoconstrictor. If mepivacaine 1 to 20,000 right here has 0.09 milligrams of levonorepinephrine per carpule, and the cardiac limit for levonorephrine is 1 milligram, then 1 milligram divided by the 0.09 milligrams per cartridge is going to equal 11.11 cartridges. So this is the same as the mepivacaine limit. So there is no limiting drug. The patient may receive 11.11 carpules of mepivacaine. So those are my calculations for anesthetic drugs. I hope this has helped in understanding how to determine what patient limits are and also for documentation purposes. But before we close, I just want to go over very quickly about calculating for nitrous oxide. If a patient has a tidal volume of 8 liters per minute, okay, and they received, say, 2 liters per minute of nitrous and, let's say 6 liters per minute of oxygen, then to determine the percentage of nitrous that they have received, which is what you're going to need to know when it goes to documenting it in the patient's chart, you need to divide the liters of nitrous, in this case it's 2. You are then going to divide that by the tidal volume of 8 liters, okay? Not the percentage of oxygen, okay? But 8 liters, so the total, and then that comes out to 0.25, which is then converts to 25%. So this patient had 25% nitrous oxide, okay, for however long they were given. Now then, to determine the percentage of oxygen that they received, then of course you'd take your 100% and you'd subtract your 25% nitrous, and then that equals your 75% of oxygen. Okay. Another example would be if a person had a tidal volume of 6 liters per minute and the nitrous was set at, well, my cursor keeps bouncing around. I hate this new computer. The nitrous was set at 2 liters a minute, and the oxygen was set at 4 liters a minute. Then to determine the percentage of nitrous, you would do 2 liters of nitrous per minute divided by the tidal volume of 6, which is then going to equal 0.33, which is then going to equal 33%. So they received 33% nitrous oxide. To determine the percentage of oxygen, then you just subtract your 33% oxygen from your 100% gas, and you get 67%. Okay, so if there are any further questions, I hope this helps. Please refer to your book. Go ahead and email me, and happy studying and good luck on Monday.